Welcome to your first flipped classroom. Keep in mind that you can pause the video at any time. We're going to begin on page 77 of your work text with lesson 2.2, solving absolute value equations. In the lesson before this one, you were graphing absolute value equations and writing absolute value functions. Today we're going to look at how do we solve these. So here's our essential question. And there's actually two different ways that you can solve an absolute value equation. One is by graphing, and the other is algebraically. So I'm going to show you how to solve really any equation graphically. Solving absolute value equations differs a little bit from linear equations in that they have two solutions. So absolute value equations typically have two solutions. If you think back to studying quadratic equations last year, you recall that commonly they have two solutions as well. I also want you to think back to 8th grade when you studied, let me get my pen here, when f of x equals g of x. And we're going to use that. Here is our first absolute value equation. If I let the left side, I'm going to circle that, be the f function equals, and if I let the right side equal g of x, okay, we have actually created a system of equations. We have the f function and the g function. On the right hand side, I've gone ahead and graphed both of these. Okay. The g function is just a horizontal line. The f function is our absolute value function. Where these two functions intersect is where you'll find your solution. So here's one solution, and here's the other solution. And what we want from each of those is the x value that corresponds with that point of intersection. So that would be when x equals 2 and when x equals 8. So there are our two solutions, meaning we can substitute 2 back into the original equation, simplify, and we get 2 out. If we can take 8, and we can substitute 8 back into the original equation, simplify, and we get 2 out as our answer. So I'm going to move back over to the left and fill in our two answers. We had x is equal to 2 and x is equal to 8. Now, thinking back to last year in Algebra 1, and the graphs that we could have for systems of equations. And we're going to answer this reflection question number 2. Is it possible for an absolute value equation to have no solutions? So think back at the graph or look back up at the graph above. Can you picture or draw a graph where there would be no solutions? I can think of one. It might look like, here's my absolute value function. And here's my g of x. So there's two different functions here, but they're never going to equal each other. So that would be no solution. What about one solution? I'm going to draw my absolute value function as a reflection. And I'm going to draw my g of x where it's going to intersect only in one spot, right here. In that case, we would only have one solution. So to recap, so one way to solve an absolute value equation is to graph the left side of the equation, Then graph the right side of the equation, look for where the two functions intersect, okay? And that point of intersection, the x value, is your solution. On the next page, I'm going to show you how to solve absolute value equations algebraically. The first step is always to isolate the absolute value expression on one side of the equation. After you have isolated the absolute value expression, we're going to rewrite it as two separate equations connected by the word or. Your math book uses the word called a disjunction. You know the word or from English class as being a conjunction. We're going to go down here to example 1, and I'll show you how this works. So in example 1 here, we have the absolute value of 3x plus 2 equals 8. We need to isolate that absolute value expression by subtracting 2 from both sides. Notice that once we do that, we have the absolute value expression here isolated. For absolute value, we know that the quantity inside the absolute value bars, in this case 3x, could be a positive number when simplified, or it could be a negative number because those absolute value bars are going to make it positive. So in that case, we can write two different equations. At first, we can say, well, 3x equals 6. Or we can say that that quantity 3x equals negative 6 because we know the absolute value bars are going to change this negative 6 into a positive 6. So we keep simplifying both equations and we end up with two solutions. X is equal to 2 and x is equal to negative 2. So let's try the next example, example B here. First step, isolate the absolute value bars. So we're going to add 2 to both sides. We'll create 21 on the right side. Divide both sides by 3. That leaves us 7 on the right side. And at this point, we can rewrite the equation. Using the left side, we say 4x minus 5 equals a positive 7, or that quantity 4x minus 5 could equal a negative 7. Simplify both equations, add 5 to both sides, divide by 4. So one of our solutions is x equals 3. Again, add 5 to both sides, that gives me negative 2. Divide by 4, that gives me negative 1/2. And if we were to graph our solution on a number line, we simply graph it x equals 3 and x equals negative 1/2. The most common mistake made when solving absolute value equations is forgetting to isolate the absolute value bars first, as in this step right here, before you rewrite it into two separate equations. At this point, we're going to stop the video and let you practice the your turns, number 3 and number 4. On the next page, I want to do a couple examples that show when maybe we don't get two solutions. In example 2, letter A, you start by isolating the absolute value bars. We subtract 2 from both sides, divide by negative 5, and what we end up with is this absolute value plus 1, absolute value of x plus 1 equals a negative 2. Now think about it. Is there any number that we could put in for x, add 1 to it, take the absolute value of it, and ever get out a negative number? No, we can't. So be careful with this, that once you isolate the absolute value bars, if you end up with a negative number on the right side, right, do not rewrite it into two separate equations. The answer here is no solution. Let's look at example B now. Begin by isolating the variable, isolating the absolute value bars, by adding 3 to both sides. We get 0 on the right-hand side. All right, next step, we're going to multiply by the reciprocal 5/3. That still gives us 0 on the right side. If I was to rewrite this as two separate equations, they're going to look exactly alike. because we can't have a positive 0 and a negative 0. It means the same thing. So in this case, we're just going to have one equation that makes it equal to 0. Add 4 to both sides, divide by 2, and we get x equals 2. In this case, there is only one solution. Time to stop the video again and for you to practice with your turn problems, number 5 and number 6. So let's check in on the bottom of the next page. So describe in your own words the basic steps to solving absolute value equations and how many solutions to expect. So as I recap the lesson, I want you to write. This is something I'll check in class tomorrow to be sure you answer this question. The first way to solve is by graphing. Graph the left side of the equation, graph the right side of the equation, and see where the two lines intersect. The second way is to solve it algebraically. First step, isolate the absolute value expression. Second step, look at the right-hand side of the equation. Is it a negative number? If so, you can stop right there and say no solution. If it's a positive number, you're going to rewrite the equation with the absolute value, what's inside the absolute value bars, equals a positive number, or what's inside the absolute value bars, that part of the expression, equals a negative number. Simplify, and you will either get one or two answers. That's the end of lesson 2.2. I hope you've enjoyed this flipped classroom.